welcome. So the game I'm going to be hacking on today is called Juggle Panic. I'm going to show a quick preview of it just so that we have context. So this is a game I made in about a day. It's very ugly. It's a little multiplayer game where you have these two little cute people. You throw balls back and forth. You try to catch the balls. If you drop 5 balls, you lose. And that's the whole game. And it has a couple of like game modes to vary it up, like low grab mode, things like that, big hands mode. Kind of give it a little bit extra kick, but that's basically the game. It's pretty simple. The code is very, very ugly. So I'm gonna be spending time today rebuilding it entirely from scratch. And I'm gonna be doing that all week because I want to show this at a showcase and I want it to be good and I want to add some features. So I've actually been hacking on it for a couple days already. So we have a starting point, which is this. Beautiful, beautiful. You can't catch balls or anything. All I've been doing so far is just making sure that the math for everything is exact. There was an issue in the previous version where as you throw and catch the ball, it goes faster and faster. And there's an issue where it started going too fast. You wouldn't even be able to catch the ball. It would just slip through your fingers. So I'm solving that in this one, and I've been spending a lot of time just instrumenting it so that it is perfect. And the thing I wanted to work on today is, let's open up the cart, or actually let's open up type folder. It will open up folder of the PICO-8 files. I'm gonna just open up this cartridge, which is the same file there that I loaded into PICO-8. What I want to do is, here's a neat feature. If you wanted to, if you type export export bo3.ping, and then you look at the folder. I think I'd already exported it, but you have your sprite sheet exported as a 128 by 128 pixel PNG, which is great. You can see that in ASC Sprite here. So the sprite sheet I'm working with, I just added a bunch of stuff to it. I just added some deformities of the ball. So if we take a look at the game itself here, and let's go change it so that the ball starts going real fast. All right. We change it so the ball bounces real fast, along the same path, but real fast. This is not the best experience because it's bouncing so fast that you can barely keep track of it with your eyes. You can't really see the arc very much. So what I thought a cool project could be is, let's make it so that as the ball bounces, it deforms a bit. And that's kind of what I've drawn into the sprite sheet already. So this is like a ball that's traveling like super fast up and to the right. And then this is a ball that's traveling super fast horizontally. So instead of just drawing this little circle ball all the time, I want to draw that deformed ball. And this works on 2 levels. One, physically, when things accelerate quickly, they actually do deform a lot. Like if you ever see an image of like someone hitting a baseball with a baseball bat, like the baseball squishes a ton and then it kind of ripples outwards. So this kind of simulates that a little bit. And then there's another level where our vision kind of has a frame rate, and if something is moving fast, it will perceive it as a kind of a slur, a blurred movement between that, and this kind of simulates that too. And perceptually, like, we are also used to this in animation too, and movies which go at 24 frames per second but have more exaggerated blur even than our vision. So it's kind of hidden on multiple levels of just it implying that really fast movement and allowing your eyes to keep track of it better. But you're gonna need to do a whole lot of math to get that ball, this ball that's bouncing super fast, to be rendered like this with this blurred movement. Maybe not a whole lot of math. I haven't really sketched it out in the head. I'm sure in my head, I'm sure it's possible. I feel like I've done this once before, but it is not obvious to me how I'm going to do this. So let's start with this. Let's keep it as a very fast ball, but here's a little tip for if you want your game to kind of like render at a lower frame rate. This is a little piece of code that can do that for you. It's kind of like, let's do this. Do this. This skip frames equals 20, then skip 0. This might be an easier way to do it. So no, broke it. No, this is fine. So this is a little bit of code that basically have a counter that's incrementing, and if it's ever divisible by 20, then your code runs. Otherwise, it short circuits and doesn't do anything. So this is kind of going to be running at a 20th of the frame rate. If I do a 30, then it'll be running at 1 frame per second, essentially. And that way I can kind of keep track of the ball. This will be useful once we start adding those deformities to kind of like see them. Oh, I don't like how it's sliding along the ground there. I need to fix that. If you see it hits the ground and then it slides forward and then it bounces off, I don't want it to do that. I need to fix that. Let's do that. Ball shouldn't slide along on ground for 2 frames. Cool. So I'm gonna need to fix that, but I want to do that. I want to do that good, juicy deformity stuff, that ball deforming. So we're gonna work on that today. At least the start of today. We'll see how it goes. So go to the ball code. Let's go to that draw method. Right now, I have my own draw sprite method that basically just makes it. Let's go to that. All it does is it's the same as SSPR, this function, except I just pass in the width and the height twice, because in this game I'm gonna never want to scale sprites at all. So I just have a function to make that a little bit easier. Doesn't do much. So this, if you're unfamiliar with like the SSPR function, if we take a look here, and then if we look in that lower, if you look in the lower left corner of ASC Sprite, had this and 04855, and that's if I select this ball with the marquee select, I think it is, and then hover over the upper left corner. 048 is the upper left corner, 55 is the width and height of this area that I've selected, and that's how you tell PICO-8 what to draw out of the sprite sheet. So you can see here the same number, 04855, the x and y coordinates in the sprite sheet, the width and height of the area you want to draw, and then where do you want to draw at the x and y location. Where's my cursor? There we go. Hide you for now. So right now we're just drawing that ball, but we want to, so I think a starting point is we're gonna need to know the speed of the ball, and we're gonna need to know its angle of movement, because those two factors are gonna determine which of these sprites we draw. So if it's very fast, we're gonna draw one of the red sprites. If it's moving vertically, we're gonna draw one of these sprites. And the combination of those two factors of angle of movement and speed of movement will determine which of these sprites we draw. And then these blue ones over here are just I figure I'll have it when it bounces against a wall, we'll deform it a bit too. Some of that juicy deform. So that's what these are. And we'll put those in later. Let's go back to our game. So let's try to figure out, let's just try to have this, let's do speed first. Speed is really easily. Speed is really easy. Local speed equals square root self.vx plus self.vy times self.vy. And let's just print that next to the ball. Print vx equals speed, or no, speed equals speed self.x self.y. Let's print it to the right of the ball. Printed that in, let's print it in black. So that's the speed of, and that's kind of like taking into account x and y velocity. Put it above or below. Then I don't need to know the exact decimal. Let's floor it. I don't need to see it at least. There you go. So now we know how fast it's moving, but we don't know which direction it's moving. Great. So now we need to know the angle. How do we do that? It's angle of movement. So if we think of dx, we'll self that. This is gonna think about this for a little bit. So this is probably gonna be trig. Imagine doing some trig stuff. Gonna be the arctangent. Is that what we're gonna do? Let's look at a PICO-8 reference. See what juicy. Oh. Juicy trig functions there are. Do math. A tan 2 dx dy. Convert dx dy to an angle. That looks right. Just try this. Local angle and dx dy are just the velocity. So a tan 2 delta dx delta y. It's interesting that it's x first and then y second, because sometimes it's the opposite order because that's the order of the division, and the y component is more important than the x component, but great. Let's plop that here. Do that too. Angle. Get this above by 6 pixels. Angle equals. No, don't want to floor it. Angle. It's gonna be hard to tell. Okay, this bouncing might not be a good deal for this. So let's all equals spawn dx equals 1, vy equals 0. This will be an easier way. 10. Let's put it more in the center of the screen, and now I've just set the. It's no longer bouncing or has any gravity applied to it, so it's just gonna move horizontally. We don't need the skip frame. Not moving that fast. So angle 0 is to the right, angle 0.5 is to the left. Let's keep track of that. So angle equals 0. Ball is moving right. Angle equals 0.5. Ball is moving left. What happens if it's moving up and down? So let's say it's moving down, then it's going to be 0.75, 0.25. 0.75 for down, 0.25 for up. So that looks correct. 0.75 for down. Angle equal 0.75. Ball is down. Angle equal 2.5. Ball is moving up. That I think, and then let's verify our hypothesis. So if it's moving mostly down, but a little bit to the left, it should be just under 0.75. So if it's moving mostly down, but let's say it's moving whatever, 4 down, and then a little bit to the left, 0.2, then it should be like, this should be like around 73. 0.73. 0.74. Great. So this I think is working. Let's just do another thing where, so if it's moving to the right, then it's 0. If it's moving to the right and slightly down, this should be like 0.99 or something. Yes. Okay, great. Got a handle on it. So great. Now we got the speed. Now we got the angle. That's all good. Something to note. This is gonna fail. Speed is gonna fail if it's going too fast because there is integer overflow in PICO-8. So if speed is, so let's do this. What's the max? The max number in PICO-8 is somewhere around 3200. I forget what the exact number is, but we divide that by 2, then take the square root of that. I like math, so I don't mind this stuff. So if it's ever moving faster than 126, or somewhere around there, we'll get into some bad business. Or not moving faster. If it's ever moving faster than 126, like in both axes at the same time, then this expression will probably be above 32,000, and speed will be, then we'll be taking the square root of a negative number, and this will fail. So probably not going to ever be moving that fast, because 126 is the full screen in movement. So going from like the upper left corner to the lower right corner in 1 frame. So we're probably not going to ever hit that. I'm not going to bother checking for that case. But this is a good thing to be on the lookout for, of just like, especially in PICO-8, will integer overflow destroy my code somehow. So we don't really need this. We know what we're doing. Or let's just comment it out for now. By the way, if you have any questions in chat, feel free to just put it in the chat. Happy to answer any questions. Yeah. I'm gonna be working on this today. I'm just gonna be kind of doing my thing. This is kind of what I do most days. Just kind of like make games, do lots of math, make art. So okay, so now let's start thinking about, I think the first step is, let's start having the right sprite be displayed depending on the angle. And then let's have the right sprite be displayed depending on the speed. I think so. Angle first, then speed. I think angle will be easier to check. So let's do this. So I'm going to do my little trick here again. 15. Oh, can't see. So if it's going, I'm just gonna put in the numbers, the sprite sheet numbers for each of these. 15, 15, 5, 16. So this is, those numbers are for drawing completely vertical upwards. Maybe we should say, yeah, whatever. And then let's just do the one that's, what happened to my stuff? Out of here. If you're wondering how I created these sprites, it was not that interesting of a process. I just kind of like picked a length and then tried to draw something that looked like a ball going fast in that direction at that length. Draw a sprite 48, 1, 3, 16, 5, 2. That's horizontal, right to the right. And then we're gonna have, I'm just kind of like, the reason these are commented out is I just want to get the numbers in, and then we can reference them and use them correctly in code rather than try to do. So this is gonna be a little bit of menial work rather than try to do the logic at the same time. Draw sprite 69, 15. And then I'll know that that is mostly vertical, somewhat horizontal. 27, 84, 930. Great. The sunny day today. Nice, but I'm not gonna play outside because I want to make video games. 33, 97, 11, 11. Yeah, it's a little hard when it's gross and gray out. I have a great excuse, just like, ugh, weather. Who would want to be outside when it's like this? But when it is nice and sunny out, I don't have as good of an excuse. And then I just assert, I'm an artist. Let me do art. 39, 108, 13, 9. 39, 108, 13. 45, 117, 15, 6. 45, 115, 6. Hopefully I got all this right. We'll catch it if we didn't. So those are, now we've picked out all of the red sprites in here. We have the right numbers for it. We're not drawing any of them. Let's do this. So this is just kind of like, these are the sprites for just a 90-degree arc of where our ball could be moving, and then for the other 270 degrees, we're just gonna flip horizontally or vertically to kind of get those. So let's do this. Local flip horizontal. So when are we gonna want to flip these sprites horizontally? We're gonna want to flip them if it's moving to the left at all, which means, which we could just check with the velocity. If we're, so flip horizontal is gonna be true if self.x is less than 0, or self.vx is 0. So if it's moving to the left, we're gonna have to flip the sprite that way. And then flip vertical is gonna be similar, self.vy. If it's moving down, then we're gonna want to flip it vertically because these sprites are all upwards facing. So that would be if vy is greater than 0. Yeah. Get out of here. We don't need no math. But we're doing lots of math right now. So sort of. The next, drink of water. Next thing we're gonna want to do is let's just draw like the diagonal one for now, and then let's just have it flip horizontal and flip vertical correctly. Make sure that those are working. The way I work is I really try to check to see if I'm I do a lot of checks to see if what I'm saying actually works. Like I wrote this flip horizontal and flip vertical thing, but I don't know if that's gonna work. Not really. So I try to check every like new little increment in behavior of code right after I write it. Next, check. Okay, so if we do that, and let's get rid of this, let's draw the outline on top of it. I think I know how this is gonna go wrong already. Let's change the background to be a different color. Let's have the 1. And then let's have, we had it before it was being thrown, which means it was doing like a cute little arc thing. Have it be that way instead, not this fixed velocity stuff. And it's moving really fast. Bring that down a little bit. Really high. Because that. Okay. So it is still very, very fast. 60. So it is flipping correctly in that when it's moving up, it's upward facing. When it's moving down, it's downward facing. When it's moving right, it's rightward facing. Moving left, leftward facing. So it's doing it right. There is an issue in that I want the fat part of that sprite to always be in that white rectangle, because that's where the ball actually is, and I want the tail to be coming off of that, because players who are going to try to catch balls are going to assume the fattest point is where the ball actually is and where you can catch it. So I need that white rectangle, which is where the ball really is, to be the sprite is centered, which means we're going to need to do a little bit more math. Ball equals, go back to our balls draw method. A lot of stuff going on here. Okay. Let's do this. Local SX, local SY, 7, local SW. So these are like SW, SH, those are sprite width, sprite height. Let's say the X and Y position in the sprite sheet, the width and height, take from the sprite sheet. Self.x, self.y. This will be doing the same thing. Do it like this. SY. So the position to take from the sprite sheet, how large of a rectangle to take from the sprite sheet. And then what do we want to do? Oh, so if flip horizontal, then, well, how about this? When is it correct? When is it displaying in the right spot? It's displaying in the right spot when it is going up and to the left. So that's when it's going to be a little backwards, but I'm just going to roll with it. So that's when it is flipped horizontally, but not flipped vertically from what it is in the sprite sheet. So if it's not flipped horizontal, then, and the case where it's not flipped horizontal looks like this. So it's offset too far. It's too far to the right. We need to subtract some to get it to be at the right spot. I'm gonna SX, no. Well, XY equals self.x, self.y. So this is the XY we're gonna render it at. So if it's not flipped horizontally, it's facing right. If it's facing right, we want to subtract x minus equals. We want to subtract the width of the sprite, but we want to add. Let's add. We want to add this thing's width minus sprite's width. Yeah, that was rough. Looks right. So when it's moving left and up, it's in the right place. When it's moving right and up, it's in the right place. Let's fix it when it's flipped horizontally. or flip vertically. If flip vertical, then y plus equals. Can we just do the same thing? Is that right? Oh, cool, great. So now this is good. This is what we want. So the tail is always coming off the right spot. The bulb of the sprite is always kind of in that rectangle where the game code thinks the ball is. So this is correct. Now we need to get it so that it's displaying, so it's flipping correctly, and it should flip correctly for every sprite that we're gonna draw, but we need to draw the right sprite. So let's do this. We're just doing the red ones. So we need to basically choose between these based on angle, based on the angle. Yes. Okay. So this is the one that's going upwards, which corresponds to angle equals 0.25. Going up. And then this is balls moving to the right is angle 0. So this is angle 0. This is what we're going to want to draw. At angle 0.25, this is what we're going to want to draw. And in between, we're going to want to draw each of these. The 0, is it going to be evenly distributed? So in a 90 degree area, if we have 90 degrees of angle, and we want to choose which of these, assuming there's no flipping, let's just handle the case where it's like between, the angle is between 0 and 0.25. Which of these do we want to draw? We want to choose so from 0 to equals, draw the horizontal one. Angle from 0.25 equals, draw the vertical one. And then there's going to be a lot in between here. How many are there? There's 1, 2, 3, 4, 5, 7. 5 others. Well, this one is going perfectly x equals y diagonal. So that's going to be at angle 0.125. So angle around 0.15 equals, draw the middlemost one. This is kind of how I actually work through types of mathy problems. Just checking the stream. 0.25. So I kind of want it where just consider 0 to 0.125. Let's do it like this. Draw. Drawing will be easy. So if we have like boom, boom, our 90 degrees, and we know that this one is going to be drawn there. And then we have 2 others. We have like this, this one. These dots just represent our different sprites. Trust me, I know what I'm doing. I kind of want it where at an angle surrounding this, we're going to draw this sprite. Yeah. So in this arc, we're going to draw this sprite. In this arc, we're going to draw this sprite. Same for these 2. So it's kind of like we want to divide 0.125 into 3. Yeah. 0.125 divided by 3. Great. So if you take the angle, we subtract. Take the angle, we add 0.125 over 3 plus 0.5 over 3. So that's going to get us, that's going to change this angle to this angle. Right? No, that's over 6. Over 3 would be right. Over 6. We're going to add... I got this. Maybe I got this. Whoa, whoa, whoa. Hold on. We're going to subtract a 1/6 of the distance from here to here. And then we're going to mod it by 0.125 over 3. 0.125 over 3. Oh, this is tricky, tricky stuff. So if I were to do that, then at angle 0, we're subtracting. I want to mod it. Oh, it's so tricky. Oh, it's so tricky. We want to divide it, not mod it. That's right. How about this? Let's do something really simpler. If the angle's between here, let's draw this one. The angle's between here and here, let's draw this one. And then we can kind of just offset it from there. Let's do that. That's easier. So we're just going to take the angle, divide it by, these arcs are 0.125 over 3, which is the same as multiply that by 2, that's 0.25 over 6, 0.5 over 12, 1 over 24. So that's just 24 times angle. Floor of 24 times angle. We're getting there, we're getting there. And then we're just gonna, subtract that. What are we gonna add? So let's do this. Do local sprite num equals floor 24 times angle. Cool. So that will mean from angle 0 to 1, 0.1. From this to this, we're gonna get 0. From here to here, we're gonna get 1. From here to here, we're gonna get 2. And then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah blah blah. Does this make sense though? Does this check out? This number 24 is, we have 5, 6, 7 plus 6 plus 6, 5, 12, 24. Yeah, that makes sense. It should be 24. The right number is that. If, except here's the thing. We're gonna go 2, 3, 4, 10, 0. 0 is this. 1, 0, 1, 2, 3, 4, 5, 6. It's gonna be vertical. Then 0, 3, 4, 5, 6, 7, blah 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 blah. So let's say that this corresponds to 0. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. But then we're gonna go too far. When the angle is above 0.25, we're gonna get to 7. But we don't have a 7 one. We have just 0, 1, 2, 3, 4, 5, 6. When we get to 7, we actually want to draw this one, which is 5. It's the 5th sprite number from the bottom. So when we're at 7, we actually want to draw 5. When we're at 8, we want to draw 4. The transformation. So if we go 7 goes to 5, 8 goes to 4. What we're essentially doing is we're saying 13 minus 7 is 5, 13 minus 8, 2, no. And then 9 is going to go to 3, 2, So how do we, what's the relationship? As that number goes up, that number is going down. So we're going to want to do n minus 3. So is that 12? 12 minus 7 is 5. 12 minus 8 is 4. So yeah, we're going to want 12 minus right now. If it's flipped horizontal. If flip horizontal, then right num equals figure out the correct sprite. Sprite num equals 12 minus right num. And if we do that, then at 6 we'll get 5, or at 7 we'll get 5, at 8 we'll get 4, so we'll be drawing the right sprite. And doesn't work though. So now we need something. If flip vertical, then horizontal, we'll do one thing. Flip vertical. What do we want to do? Well, we're already handling rendering the sprite upside down. So if we just need to choose the right sprite when it's flipped vertically. So if it's flipped vertical, I want to, so this is going to be like 23. This over here is going to be 23, but we want to draw 0, and this is going to be 22. Oh wait, no, we're going to want to draw 1. This is going to be 22, but we're going to want to draw 2. So what's the relationship there? Doing that thing again, where the sprite number we get back, we want it to be something minus that number. So is it 24 minus that? 24 minus 23 is 1? Yeah, 24 minus. If flip further than sprite, 24 minus sprite. Then we still want the flip horizontal, that's correct. That should handle the case for they're both that way. Figure out the correct sprite. So now we have a number between 0 and 6. Beautiful. But we want to turn that into the XY width height. So if sprite equals 0, then here's where we can pull these numbers. Hello again, beautiful bouncing ball. So if it's 0, we want this horizontal one. There is probably a better way to do this. We're going to do it from now, like this for now. Like maybe we could have an array. Just find stuff in the array, but we'll just do this for now. So if right num equals 2, then four, 5, 6, 5, 0, 1, 2, 4, 5. Great. 2. We got that one. We got that one. 2. 27. 18. 15. Boop. Multi-cursor this one up. Boom, boom, boom. Boom. Oh, don't need this double equals, just single equals. Okay. Let's just I'm gonna set it to that for now, but this should never happen. this. But we're gonna have it that way because I don't want it to break. Not flip horizontal, blah blah blah. Sprite num, sprite num. Find the sprite in the sprite sheet. Heyo. Okay, so there you go. It seems to be choosing the right sprite angle based on the angle. Dope. It's actually not completely correct. And I know it's not. And I will demonstrate that to myself to prove it. So if it's going to the right, good, good, good. It up a little bit. Moving to the right, choose the right sprite. Left, choose the right sprite. If it's moving just very, 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 very slightly up. Okay, if it's moving very slightly up, it goes. Oh, well, that's wrong. No, code is wrong. Well, let's just get the case where it's going up and to the right. Let's get that working out correctly. So 0.125. Seven. Right sprite. Sorry, this is just this is a very thinky one, but this is kind of like what a lot of games I create have to involve, is doing this math fudging. So let's do the case where it's going. It's doing that right. It's going like that correctly. If I do 1.001, I want it to still be going that way. Great. If I do 0.9999. So this is the thing that's wrong. Is when it's just going slightly under, I still want it to be going, still want to look like it's going that way. But if it's anywhere around going diagonal, I want it to be displayed as diagonal. But right now what's happening is if it's going at a diagonal or slightly above, it will be displayed as going at a diagonal. But if it's going slightly below a diagonal, it's shown as the next sprite down, which is not how I want it to be. I want it to be anywhere around diagonal, it gets displayed as diagonal. That will be the most accurate way. So, and I'm saying diagonal as like one, vx1, vy1. So I think we get around this doing sprite num. Let's do, I think if we subtract 0.5, no, we add 0.5 plus 0.5. Then we're going to want to mod it by 24, because when it gets to 23.9, then it'll go to 24. Yeah, so we actually want it to be. Is that right? Maybe it's not. Let's just not do it. See what happens. Great. So now, when I'm spawning this ball and it's slightly under, it's still diagonal. When it's slightly over, it's still diagonal. Great. Goes off in outer space. What was that? What was happening when it was going the other way? That seems right. And let's do this. Let's have rind 2 times -1. Let's have it on load go in random direction, and we can verify if it looks correct. Correct? Good. Looks good. Not the most scientific way of doing it, but get some coverage. Wow. Could be a game of its own. Yeah, I think we got it. So there are some edge cases I want to test. What happens when it's Does it do it well when it's going perfectly horizontal? And then what does it do if it's slightly? So it's going slightly down, slightly up. Great. It's going just vertical. How does it do? Let's see it. Bounce off the bottom. Great. Moving slightly to the right as it does that. Versus left. Yes, we did it. Seems good. Let's bring back that arcing ball. Have it do those nice arcs. Oh, all right. Down. Bring it down. Yes. Look at that beautiful ball bounce. With its beautiful meteor tail. So is there anything we're not handling here? I think all the angle stuff is good. And we are done doing that angle stuff. But we need to handle the speed. At the right speed, we need to draw the right sprite. Draw. Ooh, a lot of comments in here. Ooh, this is ugly. We'll fix that up. So now, we need to make a decision based on speed. So the X location is basically what I've chosen in the sprite sheet corresponds to speed. So at the leftmost X location, that's the slow speed, and then all the way to the right is the fastest speed. So I actually, at this point, what do we call this? We don't need to, so we actually don't need to set the X because we know based on the width. Is that correct? Yes. So we actually don't need to set. We can get rid of you. Don't need to set the X because I don't need this either. Because the X is going to be based on the X location we're going to take from the sprite sheet is based on the speed. So we're going to say, okay, if it's not going very fast, just take the one at X equals 0. If it's going a little bit fast, take the X at like +1 width, 1 sprite width, 2 sprite widths, 3 sprite widths, based on how fast it's going. So SX, local SX equals based angle and this right based on speed, sprite location based on speed, and all the other 270 degrees. Draw a sprite. Draw the sprite. Yes. Making good progress. People are chatting, I can't see it. Don't know why. Maybe people just aren't chatting, which is fine. Yeah, that's good. Find the right sprite location. So if we have a speed, which is going to be a positive number, if we just take, like, let's do floor. Let's do, yeah, floor speed over 10. I don't know what the right numbers will be yet. Zero, somewhere between 0 and 0, 1, 2, 3, because those are the sprites we have, times SW. Whoa. Have I been playing music all this time? That's no good. Meh, meh, meh. Shouldn't have been doing that. That's okay. Okay, so I did that, and now it's making it green. It's using the green sprite, which is good. I want to use... I wanted to do... Let's print that speed again. See what the speeds are. So it's going at like speed. Oh, got it. So if it's going slow enough, we actually just want to display that little blue ball. We don't actually want to do any of this. So if speed less than 10, I don't know, then we'll decide. We'll decide based on feeling. Then I'm going to draw the sprite at, I think it was 0.4855. Self x, self y. Else, so if it's going slow enough, just draw a ball. Otherwise, draw a blurred version. That's everything we've just been writing. Get some more light in here. Great. So if it's going slow enough, we're going to draw that sprite. I'd be impressed if I got that right. Let's see. 0.4855. Yes. Remember those numbers from an hour ago. Just draw the ball. Just draw a ball. Otherwise, we don't need speed or angle for that either. Speed, angle, flip horizontal, flip vertical. Figure out the correct sprite. This is all the same. Ooh. Now let's figure out which sprite we're going to use. Find the right sprite location based on angle, find the right speed. Then this is going to be like floor -1. Yes. Let's do this. This -10. For 10. And we can separate these out if we want to. Speed less than 10 number. All right, we need the speed here. Of course. Okay. So the game has deemed that this is going slow enough that it should be a blue ball. I always want to print that speed. So this is going, so I think when it's going like 3, it's good for it to be a blue ball, but when it's going like 6, 5, I think that's when I would like it to be green. So if speed less than 5, do a blue ball. Otherwise, we're gonna get into blurry ball territory. Great, so now when it's approaching the ground, it's gonna turn to that green speed. I don't need this rectangle anymore. I know it's being drawn in the right spot. Oops, did the wrong thing. Outline. And then, great. And then, I don't want it to be yellow, getting into the yellow blurring right here. I think blue to green is good for this. So, throw. let's try throwing it really slowly. So that third parameter is the kind of like the duration it takes for it to go through the whole thing. Okay, if it's going slow enough, it will just be that blue unblurred ball, which is good. It's going, let's say it's going faster. I think this is the point where I want to start getting into yellow blurring. Probably. So speed, let's go back to our ball. Divided by 10. I think by the time it gets to around, maybe we'll even do that. So now it's just as it hits the ground, it's getting into the yellow blurring. Yeah, that's right. Maybe I want it to be. Okay, let's try this. Throw. 20. 10. Huh. That cutie. Skip frames. Skip. Now we need that slow speed. So it starts out going that red speed. And let's make it not go up so high so I can keep reading the speed amount. That will change the speed, but that's okay. Yeah, look at that. Now we're getting to that good blurring territory. Okay, so when it hits the ground, it looks ugly, which is why I'm going to need to do those squish frames. We're going to need to squish. Watching it to see if it looks right. And then what's the fastest I'm going to want? That's the question. What's the fastest this ball is going to move? Honestly, I think like even faster than that. Whew. Probably about as fast as it will ever go. Looks just a little bit weird that way. All that tail. Draw. So I think I might want it to be, so this is kind of like just getting into a little bit more just artsy side of things, of just being picky about how exactly I want it to work. So I think I want it to not be red so often even when it's going this fast. Means, ugh, God, that is hard. Throw. And not throw so high. So when it's going 46, that's fine. When it gets to like, even when it's at 30, I think I want it to be not the red. Yeah, I think the cutoff should be, if it's going above 30, then it should be 30 pixels per frame. Then I want it to be red, which is speed 3. And if it's going above 5, so speed minus 5. Speed is greater than 30, then we're gonna want this expression to be 3. So the speed minus 5, so this is greater than 25. Then only then do we want that to be 3. So 5 over 3, 8, 9. So now if we try this out, we have speed. If we're at speed equals 28, and we're gonna take 5 off of that, 28 minus 5, 23 divided by 9, we're gonna be at 2.5. We're at speed equals 32. That's gonna be 32 minus 5 over 9. So it's only at speed equals 32 that I'll actually get up there. I think that might be about what I want. Yes. Yes, beautiful. I think that's good. I think that's how I want it to look. Get frames. Do. Great. So it's a little hard to kind of get a sense of how it feels. So I'm going to change it. I'm going to let's stop printing out the speed because that's distracting, and let's also color it correctly. So let's make it so it's always blue. For I equals do how I so whatever color it is, draw it as blue. Reminds me I should, after drawing every entity, I should reset the colors. Pal is a function that, whoa, right. It's just a big old block. That's because in my sprite sheet, I have outlined the sprites with this dark navy blue, which is being, when I set every color to be 12, that means that became blue too, which is why the ball is now a beautiful bouncy rectangle, which doesn't look bad, but it's not what I want. So pal is a function that changes, says whenever you draw color 7, draw it as 12 instead. So like whenever you draw white, draw blue instead. Since I'm looping, I'm saying whenever you draw any color, just draw blue while drawing this ball. And also say palt 1 false or true. So this is gonna set this is gonna set 1 the navy to be transparent. If I'm drawing from the sprite sheet, I'm drawing that navy color, I'm drawing it transparent instead of blue. So now you can actually see the ball. So it's cute. It's a little sharper than I want, honestly. It's just a little bit, I think you can see the arcs a lot better. Definitely can. Here, let's say if true, then. So you can kind of see, here's what it was before, and it was just kind of a little harder to see the arcs that it's making through the air. But if we have our nice tail, you can kind of trace it out a little bit better with your eyes, see where it was. But it feels a little too sharp to me. I don't want it to feel like it's a comet. I want it to feel like it's a rubber ball. So I think I'm gonna have to edit my sprite sheet a little bit. But this code is looking good. Doing what I want. We programmed good. We did good together today. Let me just save this actually. Get rid of that. Draw ball as blue always. Clean up some of this. Just draw ball. An undeformed. Deformed. Okay. Oh, not that. So now what do I want to do now? So now, oh yeah, I was gonna commit this. Whoa, who's that guy? Get out of here. Okay. So copy our code, paste it into our committable file, go into, let's see our differences. Whoa. What? Oh, right. I didn't want to change. I wanted to change this one. Get diff. Yes. Great. Git commit am. What did we do? Make the ball deforms. And it travels. Great. So now the code is off my computer. I can breathe a sigh of relief. I like to do it where I have different files so I can kind of see where I've come. So if I load VO1, I can see that this is like where I was at that point in time, and now we're at VO4. And I just do this whenever oh yeah, you can make little balls by the way. The players can spawn balls at this point. So I like to make separate files just so I can go back and review like where I've come from and maybe steal code from previous versions if I got rid of something and then I decided I didn't like that. So let's do it's so dark so quickly. Or we've been programming for a while. I don't know. What were we gonna do? Who remembers what we were gonna do? Oh yeah, we're gonna make the sprites less spiky. I don't like how spiky that the balls look when they're going. Just a little, yeah. It just looks, it doesn't look blurry. It looks oppressive. So let's load VO4. Let's export vo4.png. Let's open that up in a folder. Drag that into my favorite pixel art editor, ASC Sprite. I don't know how to pronounce it. And let's make these less spiky. There's a trickiness in that conservation of mass won't be contained, but that's okay. Yeah, it's a shame. I would like it. So it would be nice if I could kind of do some subpixel divisions, because a ball, when it deforms, like it widens out, but it shrinks in other dimensions, so it kind of looks like it maintains the same amount of mass. I can't really do that here because my ball is such a small number of pixels. Like the most I could deform it, I couldn't deform it and still have it be pixel art. I would have to deform it in subpixels. So I'm trying to do, but it's not going to work entirely, so I'm just going to have to put up with not really being able to conserve the visual mass of the ball. I think the green looks good. I don't think I need to edit the green at all. And we're allowed to have a little bit of like tapering. That's fine. I want to alter the angle. A little bit of tapering is fine, but I don't want it to be like a spike. I don't want it to look like it's a weapon ball. I want to look like it's just a nice rubbery ball that happens to be going very fast. And maybe, oh. Turn on this light. Maybe I'll do this and I'll think afterwards that I don't actually like this either. Maybe I'll prefer the spikiness, but I want to try this. Buffing up our ball deformities. That's gonna be the name of the video. Not really. I don't think people want to watch that. They're kind of lumpy, but that's again kind of a sacrifice of having to do it like this. Is in order to preserve a sense of angle, it kind of needs lumps. Kind of need those lumps. Can't look perfect and beautiful. Maybe lumps are what make it perfect. I like pixel art, especially like this kind of thing where you're just kind of poking at pixels. Not really any stress involved. Poking at pixels. Oh wait, I'm silly. These are just rotations of these, so I could just reuse them. I guess we'll just finish what we started. Look the same. Whatever. Well, let me do it for these ones. Oh. Ooh. Whoops. Great. Oh yeah. No. There we go. Yeah. There we go. I was saying I like pixel art because there's just this kind of just get to have fun poking pixels. There's not really any accident. Like I've done painting before, and painting is very fun, but it's also a little bit stressful because you do a bad brushstroke and you might have just made your piece of art worse. In the digital medium, there's always Control Z. So now I want to import VO4 to ping, save VO4, and run it. Okay, so I do like this better. It is like, it looks less like a little meteor. I wonder if I even want it to deform that much. Maybe. Well, let's see what it looks like if it's not even deforming that much. Angle equal. So if we change this number, that means that the most it can deform is the yellow. Wait. Yeah. Yellow. This means the most it can deform is that orange. This means this means that the most it can deform is the red. Okay. Do you like this better? I think it looks better. Let's do one last thing for today. Let's get it so that when it bumps up against bumps up against the walls or the floor, it displays its squishy state. Let's do that. Ball. So we're gonna want to go into the update method of the ball. And whenever it happens that so here's the code to bounce off walls. Whenever this happens, then I want to display for one frame the bounce off walls thing. So do this. Let's have bounce dir. Yeah. So let's have a bounce dir that we keep track of, and if you bounce off the left wall, we'll say the bounce dir is left. If you bounce off the right wall, we'll say the bounce dir is right. Whoops, self dot. And if you bounce off the floor, we'll say that self dot bounce dir equals down. And we will reset that at the beginning of each frame. So when the ball bounces off of any surface, it'll get the bounce dir property set on it for one frame. And then in our draw method, we can look that up. Okay. So this is actually going to presuppose all the stuff we've written, where if bounce dir, then actually want this to be after the coloring. We want it to still be blue. If bouncer, then else. Everything else. And if bouncer equals left, then let's find in our sprite sheet. If it's bouncing against the left wall, I want it to be this sprite. And really if it's left or right. So what is this? 3688 368849. 6849. Is that right? Is that right? 368849. Yes. Beautiful. That x self.y. How about we just draw this? Okay, so we do want self draw outline. Draw outline. Draw out. Oh no, outline. There we go. There we go. We did it. Or bounce dirt equals right. And let's draw that outline. Have our skip frame, copy I. So now if it bounces off a wall, it should get, that didn't work. Bounce there. Not have any skip frames, but I already have a concept of freeze frames. Let's do this. Freeze frames 20. So you can see now it freezes for 20 frames whenever it hits a surface. Which actually looks kind of cute. Looks like it's a little froggo. Let's put that underline underneath so I can actually write it too. Oh no, there's two little froggos. Didn't even mean to do that. This with that. Doesn't really. And now it's drawn underneath. Not drawing the right thing though. If self.bounce there. Great. Now it's drawing the right sprite. It doesn't look like it's in the right position though. So draw sprite. We're gonna want self.y minus 2 probably. Yeah, that looks to be right. And if it's on the right side, we need it to be plus ternary self.bounce dir equals sprite 1 0. Yes. 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 Great. So now it's bouncing off the walls. We want to bounce off the floor too. Else if self.bounce dir equals down, then what do we want to do? We want to draw sprite self.x self. Probably going to be minus 2 also. Let's check to see where my 2, 4. Did I do this right? Yeah, 4. 24, 76, 9, 4. 4, 76, 9, 4. Now it should bounce off the floor. Not quite, just 1 pixel off. Plus 1. Great. Let's get rid of those freeze frames. Ooh. We set the freeze frames to 1. And we get rid of that draw outline. It's not squashed enough. I think that's because Yeah. So I drew these 2 levels of squashed based on how fast it's moving. So let's do that too while we're doing this. Uh-huh. Yeah. Oh, Sprite. Sorry, lost track of what I was doing. Right. So we are drawing this sprite right now, but if it's moving really fast, we're gonna want to draw this sprite. Let's do the vertical one first. So if bouncer is down, then so this is the only difference between this sprite and this sprite is this one is at y equals 80 and this one's at y equals 76. So if ternary speed is greater than that speed, give me that speed. If speed is greater than how much? 20? Actually, we don't really want self.vy. We don't really care about the speed, we just care about the vertical speed for whether it's bouncing down, because basically I'm choosing how squished it gets when it hits the floor, and that's really dependent more on the vertical velocity rather than the horizontal. In fact, I don't think it's dependent on the horizontal at all. So if self.y is greater than 20, so if it's going faster than 20 pixels, what, 20 maybe downwards, then we want to do 80. Otherwise we'll do 6. That'll just be, if it's going really fast downwards, draw this one, otherwise draw this one. They're not the best sprites right yet, but change them up. Well, no. Load. Print. Where's that print? Got rid of it. Is that right? UI is good. Ugh, look at the skip frames back. Oh, maybe I'm really misjudging it. It really might not be going that fast. It really might not be going that fast. We're gonna have to print self.vx, vy, self.x, self.minus 10, 7. Let's draw that velocity. So it's going -50. Oh, right, because after it bounces, it's going upwards. So the velocity isn't downwards. So silly. Would have taken me a while to catch that. If bouncer equals down, self.vy is less than -20, then draw the very squished one. Otherwise, draw the only so squished, so little bit squished one. Do squish, max squish. That is an ugly sprite. Need to fix that. But we can do that later. I want to make sure the logic is working. Let's do this. What are the script frames? Oh, it looks so bad. Just like a little pong paddle came out of nowhere to bounce it. But let's test to make sure that when it's not going too fast. Whoa. What's going on? Stop that. Sorry about that. Where? Howdy, Bacon. Thanks for joining the stream. Okay, so now in this case, when it hits the ground, it does do the teeny little bounce. Bloop. Which gives it a little bit of life. Well, perfect. And if it's going a little bit faster, let's try to find the point where we want to do this super squished. I think this is still a speed where that level of squish is fine. Maybe it's right on the edge though. Bump. So what speed is it going when it hits? Okay. Speed I'm at. Let's get those freeze frames back. I had the freeze frames Excuse me. I have the freeze frames in because I think it might give it more oomph if the ball freezes for a moment when it hits the surface. But I might be wrong about that. Might take it out. Okay, so at this speed, when it hits the ground, it's going -9 upwards when it bounces off the floor. So I'd be willing to bet that the break point I want is like -10. So if I go back to my draw method, break point less than -10. So right now we'll still have it be the teensy squish. And if it's going faster than that, if it's going 57, then it's going to be the, oh right, going faster than that, then it'll be the big squish. And this is just looking at it when it hits the ground, not when it hits the walls. Freeze frames equals, get rid of you. I feel like that's still a little bit much. I think it should still be doing the minor squish. Let's try this now. Say it's going a little bit faster. Or no, that's slower. 20. Yeah, that seems about the speed where it should be doing the big squish. Which I still need a new sprite for. I mean, I could just do this right now. What do I want the sprite to look like when it's getting squished? So this is 4 pixels high. What if this was just 2? What if it just looked like that? What? Come on. Yes, I think that's better. We'll do the same thing over here for when it's bouncing off the walls again. Thanks for everyone again. Everybody join the stream. Supporting some good PICO-8 development. Let's do the same thing for when it bounces off the walls. So we're drawing it. The difference between the bouncing off the walls hard versus soft. This one is at x equals 36. This one is at x equals 40. You can see we're drawing at 36, so we need to say 40 or 36. If self.vx, if abs, absolute value function, print abs -4, 5. Color. Yeah, okay. If the absolute value of the x value is, if it's going greater than 15, then we're going to draw the big splat, otherwise the light splat. Do those freeze frames again. It's so hard to see those little details. And it's moving so fast, but I need to move fast so I can see the difference between the big splats and the small splats. Big splat, that's a small splat. So it's going 9.9, so it's actually not going fast enough to trigger the big splat. Bro, boom, boom, boom. -7. Still not. What is this? Oh, right, because I'm drawing the y velocity. I want the x velocity. Let's just draw it at a fixed point, 2020. Go in x, -5, 5. So what's the cutoff for what I want it to be a big splat? I want it to be 15. Bro. Oh. Yeah, there we go. Ooh. Rendering in the wrong spot. Oh, right. So I can see there's 1 pixel of 1 pixel between the ball and the wall. And that's because I'm not flipping it. So I need to flip it if self dot bounce equals left, and it needs to be flipped. Boop boop. Great. Let's take away those freeze frames. Keep toggling these on and off. Maybe I should just. I won't need to after this. Looks very bouncy. Yeah. Take away that print statement. Let's mess around with that throw function a little bit. Ooh, it does look rubbery. That's good. Oh, it does look good and rubbery. Great. I don't know how to feel about that wide splat. Well, we'll just keep it for now. I think it's good. Yeah, I think it's good. Maybe it needs a little divot. Kind of get that sense of like it's deforming outwards. When I say divot, I mean something like this. Loop. Which way is this going? That way. I don't know if that'll look good. I think it looks fine. Yeah, I think that's right. All right. Dope. We made a bouncy ball to give a sense of what it was before, just so we can admire our work. Used to be. Why? What are you complaining? Unexpected, simple, near local. If true. I don't know. And yes. So this is what it was before, which is fine. Stylized. Or not stylized at all, really. A little bouncing ball. This is what it became. May want to tweak a little bit. It still doesn't look perfect to me, but I think it looks a lot more dynamic and a little easier to follow for the eyes. Yeah. Alright, I'm happy. Alright, well thanks so much for stopping by. We made a bouncy ball. It was good work. We did that over an hour and a half. That's good stuff. Thanks so much for joining. I'm going to be streaming probably for the rest of the week too, making this game, expanding on it, making it better. So, yeah, until next time, have a good evening.